Very good morning, students. Today we can continue the topic of physics, that is the force. Okay. The last point which we have learned is the conservation of momentum. Okay. Law of conservation of linear momentum. And this law states that if no external force is acting on the system, then momentum before collision is equal to momentum after collision. Our total momentum in an isolated system will be remains constant. So that is the law that which we have learned. And the examples which we have learned is which one? Gun and bullet system. Okay, initially both they are in the rest position, but after the bullet has been fired from the gun, the velocity of the bullet is called as the muzzle velocity. The bullet is going to move with that muzzle velocity, that is a very high velocity, and the gun is that means recoil of the gun is going on. That velocity is called as the recoil velocity of the gun, but that is very small. But the totally m1 u1 plus m2 u2, that is equal to 0, and which should be same as m1 v1 minus m2 v2, because the bullet and the gun, they are in opposite direction. But finally m1 v1 is equal to m2 v2. So these equations which we can solve for the numericals also we can use this equation. Next example which we have given is the bomb. Okay, when the bomb has been thrown, then all the fragments have been scattered in all the direction with the different velocities, but the total momentum, if you can calculate, so that momentum will become 0. So this is the conservation of momentum. Today we can proceed for the next point. So that is what is the amount of work done. Okay, so in physics there are two types of work done. Okay, actually in physics we can say that is the different work done, and actually there are the two types of work done, means one is the physical work done and one is the mental work done. Okay, sometimes the people are telling, sir, I am sitting here for a long period of time, I am doing some work. So but if there is, according to the language of physics, if there is no displacement, there will be no work. So therefore this is the physical work and one is the mental work. Okay, so therefore mental work we can remove. If there is no displacement, this work done we are keeping away. So now only come to the point, sir, what is exactly the definition of work done in the language of physics. So suppose there is one block, okay, and if you are applying a constant force on the block, okay, so now that work done is also due to which force you are applying. So that is the fixed force or the variable force. According to that, this work done is again classified into two types. Due to the constant force first, which the work done is due to constant force which is applied on the block or on the body. Suppose this is the block, okay, which is lying on the table, we can consider like this, okay, and if you are that initial velocity of that your block is 0, and as soon as you are applying the force to that block, the block is going to move in the forward direction. Okay, so here in that case this will be the displacement of the block, but if you are applying the force, so there will be some displacement which takes place into the block. V will be the final velocity of the block. And here in that case, if I want to find out how much work has been done, then according to the definition of work is the product of force into displacement. Force into displacement. Here in that case force is also constant and displacement is also constant. So therefore work done is equal to F into S. So this is the formula for the work. Okay. Once you got the formula for the work, then now if the same case, if I will take for the constant force only, but here suppose this is the body, okay, which is lying, that means on the earth surface. Okay, this body is lying on the earth surface. Okay, suppose there is a constant force which is acting on the body, okay, but this force which is making some angle theta, okay, then at that time you have, if you want to find out the work done, then here in that case you have to divide this component of the force, because when you are applying the force in this direction, body is moving in the forward direction, this is the displacement which is produces into that body. So now here in that case force can be that means resolved into two components. The one component along the x-axis is f cos theta, and one component along the y-axis is f sin theta. Okay, so now here while you are calculating the work done along the direction of displacement, so therefore the component of force is f cos theta into displacement, or we can also say that f s cos of theta, or we can also say that f bar dot s bar. This is the dot product of two vectors, that is force vectors and displacement vector. So now here, depending upon the theta, so if your theta is here 0, then at that time we can say that this work done is the positive work done, means force and displacements along the same direction. Okay, you are applying the force to that any body and body is moving along the same direction, so that is called as the positive work done. But in case if theta is equal to 180, then at that time this work done is said to be negative work done, because cos of 180 is -1, and so therefore this work done is negative work done. Okay, you just remember that things. Next, if theta is equal to 90 degree, then the work done cos of 90 will be 0. Okay, so now suppose coolie is carrying the luggage on his head, then the force is acting in the downward direction, displacement is in the forward direction, so therefore angle make is 90 degrees, so therefore work done by the coolie here in that case is 0. Okay, so positive work done, negative work done, 0 work done, so these are the different cases for the work done when the constant force is applied on the body. Now suppose if the force which we are applying is the variable force, okay, instead of now constant force, if I will take the case of variable force, okay, so then there are the different conditions again in case of variable force. Okay, if the variable force which is acting on the body. But sir, how this variable force is acting on the body? Okay, for example, if you are taking the points A and point B, okay, and in between that A and B point, now the body is moving like this, okay, A to B. So this is A to B, this is the curve, and I want to find out the amount of work done from A to B. Okay, sir, how we can find out that this amount of work done? If suppose this is the force and this is the displacement. Suppose if you are applying a force small f to that body at one particular point, okay, and because of that, if the displacement takes place, if suppose small amount of displacement, because we want to divide that curve into number of displacement, if I take a very small amount of displacement, then f bar dot ds bar, that is called as the small work done, or f bar means dw is equal to f bar dot ds bar, so that is the your small amount of work done. And if I want to find out the total work done up to one A to B, then what I have to do, I am just taking the integration from A to B, integration of dw, so then taking the integration on both sides, a b bar f bar dot ds bar. Okay, so that is equal to, so here total work done will be w, and f bar dot ds will be fs into cos of theta, integration from A to B. And again, if you are putting theta is equal to 0, then this work done is equal to from A to B f into s. Okay, and if theta is equal to 90 degree, then that work done will also becomes 0. Okay, so these are the different condition for that theta is equal to 90, for theta is equal to 0, your amount of work done is taking the integration from 0 or A to B f bar dot ds or f into ds. So that is the work done due to variable force. Again, suppose the same thing I want to calculate this work done, I can do like this also. If I will divide that curve into number of displacement, very smaller part. So suppose each part, if I will say this is dx, okay, and the force which we are applying for the first case is F1, second case is F2, F3, F4, variable force is there, and that at that time delta x1, delta x2, so these are the amount of work done. So here in that case we can also calculate here, so suppose, so small work done, we can say dw1 is equal to F1 into delta x1, so this is the small work done. Okay. Now if the same thing, if I will take the for the second case, that is the F2 into delta x2 and so on, Wn Fn into delta xn. So total amount of work done, W is equal to W1 plus W2 plus up to dash dash delta Wn. Okay, and so therefore delta W1, delta W2, if I will put the values, then I will get F1 into delta x1 plus F2 into delta x2 up to dash dash Fn into delta xn. Or we can also say that this work done is equal to summation of Fi into delta xi, where I varies from 1 to n. Okay, when it I will be varies from 1 to n, so that is the amount of work done. Or we can also say that limiting value of delta x tends to 0, summation of xi to xf, that is equal to f into dx. So that is also your work done. Okay, so this is due to variable force. Okay, so this is the second case. In case of the variable force, we are able to find out the work done. Now third case, suppose I want to find out the work done in case of the variable force. So the third method will be, now suppose this is the curve. Okay, this is the curve. And if so, this is the angle theta which has been made along the ds. Okay, and so this is the f bar. Okay, or we can also say that if this is the theta and if this is the dx. So here in that case, okay, so this is this direction. So here in that case also A to B, if I want to find out the work done. So work done is equal to dW is equal to F bar dot ds bar, F bar dot ds bar. Okay, but now so if this will be the integration of dW, so that will be F into cos theta into ds bar. Okay, F into ds into F cos of theta into ds. Okay, so that will be the your case. And if I want to take this integration from A to B to find out the total work done dW. Okay, so total work done will give you W. Okay, so that will be W is equal to F into cos theta into dx. But if in terms of rectangular coordinate I want to write down F bar dot ds bar. Okay, so integration of A to B, okay, F bar dot ds bar. Okay, so this is A to B. And if I will substitute the value of that work done in terms of the rectangular coordinate system, F is equal to Fxi plus Fyj plus Fzk. Okay, I, J, K are the unit vector along the x-axis, y-axis and z-axis, and dx bar is equal to dxi cap, dyj cap, dz k cap. Okay, so then the total work done can be calculated by integration of A to B Fxi plus Fyj plus Fzk. Okay, dot dxi plus dyj plus dzk. And so therefore your answer will be fx into dx A to B plus fy into dy A to B plus fz into dz from A to B. So that will be the total amount of work done in case of your variable force. Okay, so these are the different ways how we can calculate the amount of work done. Okay, what the things he has given to you, according to that we can find out the amount of work done. Once you got that this variable work done, then now next point is means work done due to the constant force and variable force. What is the work energy theorem? What is work energy theorem? Okay, what is the work energy theorem? So it's very simple. What is the work energy theorem? It's a very simple. You see here. According to this theorem states that the amount of work done by a force in displacing a body measures the change in its kinetic energy. Means amount of work done is equal to change in its kinetic energy. Change in its kinetic energy. Okay, means whatever the work you are doing on the body, so that work is nothing but you are just changing the kinetic energy of the body. Sir, how these things can be? How the only you can change the energy of the body? So now it's very simple. If you can say work done is a positive. Okay, when work done is a positive, that means force and displacements along the same direction. And here in that case, when you are applying the force to that body, the kinetic energy of the body goes on increasing. Okay, means the first case speed of the particle increases because final kinetic energy is greater than the initial kinetic energy. Then and then only work done is said to be a positive. Okay, and when we can say that work done is negative, then at that that time the kinetic energy of the particle goes on decreasing. Means final kinetic energy will be less than the initial kinetic energy. Then and then only we can say that work done is negative. Okay, why these things happens? Because that second case the speed of the body goes on decreasing. Okay, so that is the condition for the work done, that is equal to changing in kinetic energy. But sir, how we can prove that things? The proof for that work done is nothing but changing kinetic energy. Okay, so I will start basically if I want to prove that. So dW is equal to amount of the work done is equal to F bar dot ds bar, or F into ds. If I will take in magnitude, F into ds. So this is the amount of work done. Okay. But sir, what is your force? What is your force? So if I want to find out the force, so the force is equal to mass into acceleration into ds. Okay, so that is the amount of work done, because what I want to prove, work done W is equal to change in kinetic energy, means final kinetic energy minus initial kinetic energy. But how I can prove that things? Okay, so here dW is equal to m into dV by dt into ds. Okay, so dW is equal to m into dV by dt into ds. What I will do now, m into ds by dt into dV, ds by dt into dV. Now what is ds by dt? That is nothing but that change in velocity or rate of change of displacement with respect to displacement, means it is the velocity with respect to v. And if I want to find out the total amount of work done when the velocity of the body is changes from u to v, m into v into delta v, then your formula will be m will be constant quantity, integration of v will be v square by 2 from u to v. And if I want to put that value upper limit minus lower limit, so this answer will be total work done is equal to 1/2 m v square minus m u square. Okay, so that will be your formula. Or we can also say that W is equal to 1/2 mv square minus 1/2 mv square. What is that 1/2 mv square? That is the final kinetic energy minus initial kinetic energy. Okay, so that is the amount of work done. Okay, so work done is equal to change in its kinetic energy. So this is your work energy theorem that we have been proved. Then after that, next point which we want to learn is the collision. Okay, sir, what is exactly collision? Because this is also part is there in the force, so that is collision. Okay, now collision means actually there is the interaction of two particles, when two or more than two particles colliding with each other. Okay, so that is called as the collision. While the collision which takes place, not necessary every time there will be a physical contact of one body with the another body. Maybe they are colliding, but still there is no physical contact is also there. So that is also called as the collision. Okay, so sir, no physical contact, how it can be possible? You know, the Rutherford's alpha scattering experiment. Okay, when Rutherford's alpha scattering experiment, when that means your alpha particle strikes on the nucleus. Nucleus is positively charged nucleus is a positively charged, and your alpha particle is also positively charged. When the positively charged alpha particles incident on that your nucleus, so then what happens? There is a strong repulsion is going on, and due to that strong repulsion, that there will be that alpha particle retraces its path, but still there is a collision is going on. Okay, so that is called as the collision. Okay, so now once you got that collision, so then there are the different types of collision. So which are that types of collision? Okay, you see here. First type of collision is elastic collision, which is one elastic collision. Okay, first is elastic collision. Okay, second is inelastic collision. Second is inelastic collision. Inelastic collision. Third part is perfectly inelastic collision. Perfectly inelastic collision. Inelastic collision. Okay. And one more is head-on collision. head-on collision. So these are the different types of collision. Okay, elastic collision, inelastic collision, completely inelastic collision or perfectly inelastic collision, and last but not the least, that is the head-on collision. Okay. So now sir, what is exactly meaning of all that collisions? What happens exactly in each and every collision? So now you see here, if you can talking about the elastic collision. So now the collision in which there is no loss of kinetic energies going on. When the two or more than two bodies they are colliding with each other, but there is no loss of, that is your kinetic energy. Okay. Not only that, the total energy will be remains conserved here in that case. Okay, momentum will remains the conserved. Okay, as well as kinetic energy will also remains conserved. This type of collision is called as the elastic collision. Okay, then I will define what is the elastic collision in which momentum and kinetic energy will be remains conserved. So means here m1u1 plus m2u2 is equal to m1v1 plus m2v2. Or kinetic energy 1 half m1u1 square plus 1 half m2u2 square is equal to 1 half m1v1 square plus 1 half m2v2 square. Our total energy will be remains conserved. This is the elastic collision. So this is that protons or alpha particles or the collision with the nucleus. So these are the examples of the elastic collision. Okay, or the pebbles when they are colliding with each other. So that collision is also elastic collision. So then what is inelastic collision? What is the inelastic collision? In elastic collision, there will be a loss of kinetic energy. But here, no doubt, momentum is conserved because in any collision, the momentum will be always remains conserved. Total energy will remains conserved, but here in that case, kinetic energy does not remains conserved. So that type of collision is called as the inelastic collision. Sir, how these things happens here? How the kinetic energy is not conserved here? Because you see here, if suppose I am taking a ball. And if I will throw the ball with some higher velocity towards the wall. When the ball is thrown on the wall, then when the ball again rebacks, okay, then at that time or reflects back, then at that time there will be some loss of kinetic energy is going on. Why? How sir? When that energy will be going on? Maybe at what point this ball has been collides. That point particularly there is some heat is going to get formed, means some energy has been converted into heat energy. Okay, or so what is going to happen if though you have thrown the ball with 10 joule energy, but now it will come with the 9 joule energy. 1 joule energy is be lost here in that case by the collision, or there will be a sound is going to produce cut when you are throwing that ball. So that energy has been converted into sound energy. So that will be the best example of inelastic collision. Means here energy always reduces here in that case. Kinetic energy goes on decreasing. So that is the best example of inelastic collision. Now next collision is perfectly inelastic collision. Sir, what is exactly perfectly inelastic collision or completely inelastic collision? The collision in which total kinetic energies get lost. Okay, remember first of all, total kinetic energy is going to get lost. Total energy will be remains conserved, momentum will be remains conserved. But now sir, how these things happens here? Total energies get conserved. Means for example, if I will take a mud, and if I will throw the mud on the wall, what is going to happen? The mud is completely sticks to that wall. Means the mud is not going to come back. Okay, again it will not that means reflects from that particular point. Means total energy has been lost here in that case. Okay, mud has been thrown on the wall, it will be sticks. Or in perfectly or completely inelastic collision, after colliding that two bodies, they will act like as a common body. They will be acts like as a one body, and they are moving with the common velocity. Now here in that case, wall and the mud, both they have the velocity 0. Okay, so therefore they are going to get, that means that velocity will becomes 0. So here in that case, so that is called as a perfectly inelastic collision. And now sir, what is the head-on collision? The collision in which after collision, that bodies they are moving along the same straight line. Okay, before and after collision, the velocities of that bodies along the same straight line. So that is the head-on collision. Okay, head-on collision. Okay, means they will collide with each other, and after and before collision, they are moving along the same straight line. So the best example for that is, if you are taking the example of two railway compartment, when they are moving on the railway that platform, and when they are going to stick with each other or when they are colliding with each other, they are moving along the same straight line but in opposite direction after collision. Okay, so that is called as the head-on collision. Okay, so these are the different examples of, that means, your collisions. Once you got the idea about the collision, then now question arises, sir, what are they? That means in perfectly elastic collision. Okay, find out the velocities of a body, in elastic head-on collision. Head-on collision means their bodies, they are colliding with each other, but that collision is head-on collision. Okay, so then what these things is going to happen? Suppose this is the first body having the mass m1 moving with the velocity u1. Second body having the mass m2 moving with the velocity u2. Okay, and after some times, if here again u1 is greater than u2, these two bodies, they are colliding with each other. Okay, so that this is the collision is going on. First body m1 having mass m1 m2, and after collision, first body is moving with velocity v1, m1 is moving with v1, m2 is going to move with v2. Okay, so this is the condition is going on. This is before collision, and this is after collision. So here in that case, here if this is the head-on and that is the elastic collision, then what are the things are going to be remains conserved? So here, first of all, kinetic energy is conserved, total energy is conserved, momentum is conserved. So if you can write down the equation, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. First equation is going to get satisfied. Second expression, if I want to write down kinetic energy, 1/2 m1 u1 square plus 1/2 m2 u2 square is equal to 1/2 m1 v1 square plus 1/2 m2 v2 square. This is equation number 1. This is equation number 2. Okay, so you please write down both this equation and solve this equation. You will get the equation for velocities, that these final velocities v1 and v2. If you know the u1, u2, m1, m2 after collision, then the final velocities has been given by the formula. v1 is equal to m1 minus m2 upon m1 plus m2 into u1 plus 2 times m2, okay, m1 plus m2 into u2. So this is your first velocity. Okay, and for calculating the second velocity, if we want to find out the second velocity, your example is, that is v2 is equal to, you just interchange that coefficient. So instead of m1, I will say m2 minus m1 upon m1 plus m2, okay, into u2 plus 2 times m1 upon m1 plus m2 into u1. So this is the second that means your velocity. Okay, v1 and v2, these are your final velocities. Okay, so then after getting that velocities, there are the different conditions are there. Which are that condition? Okay, so which are different conditions? So first condition is, if suppose m1 is equal to m2, now these bodies, they are moving, that means in the forward direction along the one axis only, and if they are colliding with each other but the masses of that both bodies are the same, then after collision they will interchange their velocities. Okay, their velocities is going to get changed. Means suppose first body which is moving with u1, then this body is going to move with the final velocity v2. Second body which is going to move with the u2, this body is going to move with the initial velocity v1. Okay, so how these things is going to happen? So now if you put the value of m1, m2, so then v1 is equal to, you see here, this factor will become 0. So then this factor will be m1 is equal to m2, means 2 times m2 upon 2 times m2, m2 get cancelled. What as example 2 will also get cancelled, means only v1 is equal to u2. Means the second body which is going to move with the velocity u2, then now it will becomes the final velocity v1. The velocity of that body will be v1. And the second case v2, if you want to find out, so again this factor will become 0 in that factor. So now m1 is equal to m2, means this is going to get cancelled again. v2 is equal to u1. Okay, means what you have observed, u1 becomes v2 and u2 becomes v1, means they are interchanging their velocities. Okay, so this is the first condition. Second condition, if suppose m2 is very greater than m1, m2 is very greater than m1 and second body is in the rest position. Okay, means I will neglect the m1. Suppose I am throwing the ball on the wall, mass of the wall is too large and ball mass is negligible, wall is in the rest position. After what happens, then this body, the second body will be remains in the rest position. That means v2 will be 0 and v1 will be, that means reflecting this body, or it will be bouncing back. So therefore that velocity will becomes negative. Now we will put the value. Okay, m2 is greater, means that v1 is equal to मुलांनो, हा जर m1 तुमचा लहान असेल म्हणजे याला 0 करू, म्हणजे मायनस m2 अपॉन m2 म्हणजे कट झाला म्हणजे मायनस u1. ओके, मायनस u1 आणि इकडे हा u2 तो 0 होता, म्हणजे v1 becomes minus u1, means they are, that velocity will be in negative sign and second body will be remains in the same velocity, that is in the rest position, it will be rest. Okay, m2 खूप मोठा आहे, m1 हा तुमचा लहान आहे, म्हणजे कटच झाला, m2 गेट कॅन्सल, म्हणजे हा तुमचा u2 राहिला आणि हा तुमचा परत मुलांनो हा u2 ची किंमत तुम्ही 0 टाकली, म्हणजे हा पूर्ण फॅक्टर तुमचा 0 झाला. आणि आता इकडे बघूया, m1 तुमचा खूप कमी आहे, म्हणजे हा जर 0 झाला तर 0 अपॉन एनिथिंग विल बी 0, म्हणजे दुसरी बॉडी जी आहे ती तुमची रेस्ट मध्ये राहणार. आणि मुलांनो तिसरी कंडिशन मला अशी घेता येईल ह्या केस मध्ये, इफ सपोज m1 इज व्हेरी लार्जर दॅन m2, m1 हा m2 पेक्षा खूप मोठा असेल, तर ह्या केस मध्ये मुलांनो आपल्याला परत आता असं कन्सिडर करावं लागेल की m1 समजा u2 दुसऱ्या बॉडीची वेलोसिटी 0 आहे, रेस्ट मध्ये आहे, आणि मी एक मोठी बॉडी त्याच्याकडे फेकली, तर काय होईल माहिती आहे का मुलांना, आता जी पहिली बॉडी आहे ती त्याच वेलोसिटीने मूव्ह होईल आणि दुसरी बॉडी डबल वेलोसिटीने मूव्ह व्हायला लागेल. सर आता कसं बघा, आता मी पहिल्या केस मध्ये आता हिची समजा वेलोसिटी v1 काढायची होती, आता मी काय सांगितलं तर v1 ला m1 खूप मोठा आहे, म्हणजे m2 ला 0 केलं, म्हणजे हा कट झाला, हा झाला तुमचा, इथे राहिला तुमचा u1. ओके, v1 विल रिमेन्स u1 आणि तुम्ही u2 तर 0च म्हटलाय, म्हणजे इथं फक्त काय येईल तुमचा u1 राहील. आणि v2 च्या केस मध्ये मुलांनो इथे जर बघितलं तुम्ही तर m1 खूप मोठा आहे, म्हणजे हा मायनस, ओके, आणि u2 0, म्हणजे हा पूर्ण फॅक्टर 0 झाला. आणि इकडे जर मी आलो तर m1 मोठा आहे m2 पेक्षा, म्हणजे 2 टाइम्स m1 आणि हा m1 गेट कॅन्सल, m2 तो 0च आपण पकडलाय, 2 टाइम्स u1, म्हणजे दुसरी जी बॉडी आहे ती त्याच्या डबल वेलोसिटीने मूव्ह व्हायला लागेल. v2 is going to move with the velocity of 2 times u1 and v1 will becomes u1. So these are the interchanging of that velocities. Once you got that things, then now next point we want to learn is the elastic collision in two-dimensional case. Okay, this is the one-dimensional case along the same straight line. Now we want to learn the collision in two-dimensional case. Okay, so that things also we want to discuss, we want to learn. Okay, तर मुलांनो आता आपण त्याचा पण अभ्यास करून टाकूया. ओके, सो द इलास्टिक कोलिजन in two dimension, in 2D. Okay, elastic collision in two dimensional case. Now suppose for example, if suppose we can consider there is one body. Okay, so this body having the initial p body having the initial velocity u, and this body there is another body that is supposed to be pq body having the velocity u2 which is 0. Okay, and now this body having the mass m1, this body having the mass m2, and this body initially moving with some momentum m1 u1, second body having the momentum 0, and after that when this body collides on the second body, then what is going to happen, first body is going to move with the velocity v1 but making some angle θ1 with the x-axis. Okay, so this is the first body p, okay, having the velocity mass m1 which is moving with velocity v1, and the second body that is having a mass m2 and that is velocity is final velocity is v2. Okay, m2 v2 and this body is q. Okay, So making some angle theta with the x-axis. So then this type of collision is called as the that is a two-dimensional collision. For example, in carom board, when you are, that means the one striker strikes, then at that time what is going to happen? So that there will be, after collision, they are moving with the different direction. That to strike, means strikers falls on that your pebbles, then at that time they are moving with the different direction. So now here in that two-dimensional collision, sir, what are the conditions? So here momentum, if you can consider, m1 u1 plus m2 u2 will be 0 is equal to, okay. Now here, as this velocity v1 has been classified into two components, that is the v1 cos of theta 1, and here this will be v1 sin of theta 1, and here this will be v2 cos of theta 2, here in that case v2 sin of theta 2, okay. So m1 u1 along the x-axis, I will say m1 u1 plus that 0 is equal to m1 v1 cos of theta 1 plus m2 v2 cos of theta 2. So this will be the first equation, okay. And along the y-axis, if you can consider, that equation will be m1 v1 sin of theta 1 is equal to minus m2 v2 sin of theta 2, okay, because they are in opposite direction, okay. हे y axis चे component दोघे एकमेकाला opposite. हाच इकडे आणला मुलांनो, m1 v1 sin theta 1 plus m2 v2 sin theta 2 is equal to 0. So, and if you want to write down the component of energy also, so what will be the kinetic energies also remains constant, 1/2 m1 for the kinetic energy, okay. Kinetic energy is also constant, 1/2 m1 u1 square plus 0, because u2 is 0, is equal to 1/2 m1 v1 square plus 1/2 m2 into v2 square. In this is the third equation. So if you solve that, all the three equation means most of the components, means the four components are known to you, then the next component, the three components are known, fourth can be calculated, because here there are the four variables are there, m1 v1 theta 1 theta 2, okay. So therefore here in that case three components are known to you, then we will be able to find out the fourth component. So this is way how that elastic collision takes place in two-dimension case, okay. So now you can solve that remaining conditions by putting the different values, different thetas. What will be the theta glancing angle? Theta is 0 or theta is that means 90 degree. According to that you can find out the different conditions. Now one more things that we want to find out in collision, that is the coefficient of restitution. What is the last point we want to finish here? Coefficient of restitution. Okay, आता coefficient of restitution काय असतो सर? त्याला आपण E ने दाखवतो मुलांनो. Coefficient of restitution means E. So coefficient of restitution is defined as, it is the ratio of velocity of separation, velocity of separation or after collision, okay, to the velocity of approach, velocity of separation to the velocity of approach, means this is the before collision, okay. So here in that case velocity of approach, so that can be given by, and that is negative sign, means v1 minus v2 upon u1 minus u2, or we can also say that v2 minus v1 upon u1 minus u2. So case number 1, if v2 minus v1 is equal to u1 minus u2, then what will happen? E is equal to 1. So then that time we can say that this is the perfectly elastic collision. Means there is no loss of kinetic energies going on, okay. But in this second case, समजा मुलांनो मी अशी केस consider केली, okay, v1 final velocities are the same, v1 is equal to v2, okay, after collision their velocities are the same. Then the elastic collision म्हणजे काय रे, these two bodies they will be after collision they will be acts like as a one body after combination of the two bodies, means wall is thrown on the mud is thrown on the wall, they will be make it as a one body and they are moving with the common velocity v1 is equal to v2, and if I'll put this value, that answer will become 0. So answer will be 0, means this is the perfectly inelastic collision, perfectly inelastic collision. मग या दोघांच्या मधलं जे कोलिजन आहे मुलांनो, मीन्स ई इज लाईज इन बिटवीन 0 and 1. म्हणजे मुलांनो हा जो ई आहे हा कसा असला पाहिजे माहितीये, हा इट इज लाईज इन बिटवीन 0 and 1, म्हणजे 0 पेक्षा मोठा आणि 1 पेक्षा लहान, अशी जी कंडिशन असेल तर तिला आपण नाव देऊया फक्त इनइलास्टिक कोलिजन. काय म्हणू याला, फक्त इनइलास्टिक कोलिजन. म्हणजे त्याची एनर्जी काही थोडीशी काय होणार मुलांनो, लॉस होणार, पण ती पूर्णपणे एक पण राहणार नाही आणि 0 पेक्षा त्यांची जास्त राहील, इनइलास्टिक कोलिजन. ओके. मग मुलांनो ई इज ग्रेटर दॅन 1 असू शकतं का? हो, होऊ शकतं मुलांनो. समजा ट्रॅकर्स मध्ये म्हणजे कायनेटिक एनर्जीची इन्क्रीज होतो, असं काही होत नाही, पण मुलांनो जी जी स्टोर एनर्जी असेल, ज्यावेळेस तिचा स्फोट होतो त्यावेळेस समजा ट्रॅकर्स मध्ये ती पोटेन्शियल एनर्जीचं रूपांतर कायनेटिक मध्ये झालं तर त्याला सुपर इलास्टिक कोलिजन सुद्धा म्हणतात. त्यावेळेस त्याचा फॅक्टर येतो इज ग्रेटर दॅन 1. सो दीज आर द डिफरंट टाइप्स ऑफ कोएफिशिएंट ऑफ रिस्टिट्यूशन. ओके. सो once you got the idea about all these things, then I will give the 1 or 2 numericals on that. You can solve these numericals so that you will get the idea about that collision. Okay, एक numerical घेऊ आपण मुलांनो. चला घ्या आता. Two bodies, okay, that collision, on the collision I will give the one example to you. We can solve that example. Okay, two bodies. Okay, hope so you understood each and everything. Okay, and now you are solving the problem on collision. You can practice more problems also. You have the lot of homework has been given to you. You can practice that things also. Okay, you have the notes with you. So now the two bodies of a mass 5 kg, m1 is equal to 5 kg and m2 is equal to 3 kg moving in the same direction along the same straight line with the velocities, means v1 is equal to 5 meter per second and v2 is equal to 3 meter per second. v1 is equal to 5 meter per second and v2 is equal to 3 meter per second respectively. Suppose one dimensional elastic collision, find their velocities after the collision. तर मुलांनो तुम्हाला v1 आणि v2 विचारले. ओके, सॉरी ह्या काय होत्या तुमचे u1 u2 आहेत मुलांनो, u1 u2 आणि तुम्हाला पाहिजे आहेत v1 v2. चला आता मला कोण सांगतं बरं याचा v1 चा फॉर्म्युला कोण सांगतं बरं मला आता. v1 इज इक्वल टू, चला सांगा, m1 मायनस m2 अपॉन m1 प्लस m2 into u1 plus 2 times m2 upon m1 plus m2 into u2. ओके, आता किमती टाकून द्या. v1 is equal to m1 किती होता रे 5, m2 3, 5 आणि 3 8. ओके, into u1 किती होता रे तुमचा 5 प्लस 2 into m2 सांगा रे 3 अपॉन 5 प्लस 3 8 into u2 सांगा रे 3 होता. चला सांगा मग v1 is equal to 5 minus 3 2, 2 by 8 means 1 by 4 plus into 5 means 5 by 4. ओके, हे लक्षात आलं ना. 5 म्हणून 3 गेले 2, 2 and 2, 2 4 जा means 5 by 4 प्लस आता मुलांनो 2 4 जा 3 3 जा 9, 9 by 4, 9 5 14, 14 भागिले 4, 14 भागिले 4 म्हणजे ते किती येईल मुलांनो, 14 भागिले 4 म्हणजेच ते उत्तर येतं 2 2 जा 4, 2 7 जा मीन्स 3.5 मीटर पर सेकंड. ही पहिली वेळ. सिमिलरली यू कॅन कॅल्क्युलेट फॉर v2 इंटरचेंजिंग दिस व्हॅल्यू m2 minus m1 upon m1 plus m2 into u2 plus 2 times m1 upon m1 plus m2 into u1. ओके, आता इंटरचेंजिंग केल्यात मुलांना त्याच्यात किमती टाका. m2 ची किंमत 3 वजा 5 अपॉन 8 इंटू u2 ची व्हॅल्यू 3 अधिक 2 गुणिले m1 ची किंमत 5 टाका, हा 8 आला, u1 ची किंमत 5 आली. हे सर्व सॉल्व करा मुलांनो, तुमचं उत्तर यायला पाहिजे 5.5 meter per second. Okay, so these are the different examples. Okay, I think so you can solve, practice the rest of the problems. Today we'll stop here. Okay, I think so we can stop it now. Okay, so there is no problem as such. And then again one more point is there, that point I will take later on. Okay, today we'll stop here. Okay, so that will be the, thank you.